I think we can go ahead and get started. Can everyone see my screen okay?
Yes.
Wonderful.
Yep.
Great. So welcome to the March webinar. Get started. So today we'll talk about some new features, sensor updates, and then just a few general updates that we thought would be helpful for everybody using LAMP to know, as well as the usual bug report, what we are aware of, and also things that have been resolved. So first off, we have two new cognitive tests, which is very exciting. They are both attentional reward cognitive tests that were designed explicitly for LAMP by LAMP consortium partners. One is the balloon risk game and the other is the pop the bubbles. Next, we have some updates around sensors. So we have updated push notifications to allow metadata to be collected about the way users interact with their push notifications. And we also soon are going to be able to allow users to toggle on or off which sensors they would like to be collecting. Just for some context on how we are able to put that sensor data to use is when you're wearing a wearable, you are able to get that information sent to your Apple Health or your Google Fit, in which case the LAMP app is able to take that data, send it to our database so we can process it with our data pipeline Cortex and then display those graphs on the Prevent tab. And if anybody is interested in collaborating and they would like to create their own data analysis pipeline of sorts, we would be happy to work with you so we can make those graphs show up on the Prevent tab for everyone. So if you have specific algorithms to process the sensor data. And then so we have just a few updates around LAMP use in general. One is hardened security requirements for groups that are self-deploying LAMP, which means that system admins are going to need to generate passwords, reset passwords and accounts for clinicians and for patients. And then MyLAMP now requires a minimum version of Android 7, iOS 14, or watchOS 6. I won't go through all of these, but these are some bugs that we have resolved in the last month. So some large things and some small things, but all important. And then we also are aware of a couple current bugs. So if anybody is experiencing them, they are on our radar. We are working on them. But as always, please continue to submit bugs at docs.lamp.digital because that helps us get to the bottom of things and get everything working smoothly for everyone. Are there any questions about project updates, bugs, concerns? Great. Well, with that, we can move into the site spotlight, which is University of Oxford and Dr. Annika Tomlinson. So I will stop sharing, pass it over to you.
Thank you. All right, let's hope technology doesn't fail me now.
I like the skeleton in the background.
Thank you. Okay, just sorry, I'm just having to give permission. My Mac is wanting. Okay, let's try again. Good. Okay, can everybody see now?
Yes.
Super. Okay, well, thank you so much for inviting me on behalf of the Paideia team to give this talk today. It's really, really nice and a really exciting project that I'm happy to talk about. So I first must send apologies. Andrea couldn't join today, so he sends his apologies. But really, I just wanted to give you an overview of what Paideia, which is the title of the project, is all about. So a little bit about me to start. So I'm Annika Tomlinson. I'm a clinical academic working in the Department of Psychiatry in Oxford. I work with Andrea Cipriani in the Oxford Precision Psychiatry Lab. And my research interests really are all around precision psychiatry. So taking psychiatry and making it individualized, whether that be diagnosis or intervention. And that's the whole ethos really around the Paideia project. So if anybody's worked with Andrea before, we all know that one of his first questions and one of the most important things is an acronym for any project. You'll see in some of his papers as well, an acronym is the most important thing to start with. And Paideia doesn't let us down. So Paideia actually translates in Greek to education learning, and you'll see why that's relevant a little bit later. And actually does stand for something relevant as well. So it's a double one. So I think that it really does describe the trial. So it's a personalized AI, so artificial intelligence, versus a designed by experts, an individualized approach. And this was a trial to improve and protect the mental well-being during and after COVID-19. So the Paideia part that I'll talk about today is the pilot trial, and really started with Andrea and I sat talking at the beginning of COVID, so during the first lockdown in the UK. I mean, we've been in lockdown practically the entire COVID pandemic. We are still in lockdown, but it was during the first lockdown in sort of March, April last year. And we were saying that so many people, we had so many students coming to us with mental health problems, with general well-being problems. I was actually working in acute medicine at the time on the front line, and I'd see again all the staff that were just either exhausted or just really not looking after themselves and putting patients first, as we tend to do. So we wanted a way to help, basically. And so we wanted to deliver an intervention in a way that would be safe and would sort of enter a wide scale. And so we thought straight away, digital. And when we think digital, we think of John Torres. So literally a sort of half an hour after Andrea and I had this conversation, Andrea sends John a WhatsApp to say, right, we've got this idea. John gets onto Skype, and we have the idea of using MindLamp to actually host as the platform to host these interventions. So John was really keen and on board, and has been so good with his team as well at helping us get through the life of Paideia. So we started to think a little bit more then. We needed the interventions. We wanted them to be evidence-based. We knew that because of the pilot trial, we needed to keep it quite simple. So the larger trial, where we'll scale up to 20,000 participants, we look to include 4 evidence-based interventions. But for the pilot trial, we thought we'll go for mindfulness and exercise. And we've worked with a lot of people in Oxford on both of these. So we had some good contacts within Oxford, both Oxford University and Oxford Brookes. And so we asked Willem Kijken, who's in the Oxford Mindfulness Centre in the Department of Psychiatry, if he would be interested in collaborating, and Professor Helen Dawes in the Oxford Brookes University, who has worked with numerous athletes before. And they both said, absolutely, yes, this sounds great. And the digital approach, whilst people are isolating, etc., they thought was the way to go as well. So that was the sort of easy bit, is getting the collaborators on board. The difficult bit then came of, right, we want an individualized approach, and we want a dynamic, we want an artificial intelligence approach. So we, in discussions with the experts, we said, right, we need to develop a static arm, so expert-led, so where the experts would come up with a program, and it could be, when we say static, it means it's static in its trajectory. So if A happens, then B will be recommended. If C happens, D will be recommended. So it was a real static approach that it would follow the intervention. We wanted the dynamic approach to be the interventional arm, so the experimental arm, I should say. So we wanted this to be the personalized approach. So we didn't want a one size fits all of, if you like running in the morning, go running in the morning. We wanted to take it a little bit further. So we wanted to use AI in this approach and actually finding what factors, what predictors are there that can change people's trajectory along their program that's been predefined. So let me just show you the design of the trial because the next, I should say then, so the dynamic arm, where do we get the AI from? Where do we get the data from? And that was the next question. We couldn't run a trial of static versus dynamic without a continual algorithm being developed. And the way the interventions have been developed, we've done 2 12-week programs, 1 exercise and 1 mindfulness. So people progress over the 12 weeks. It's actually an 8-week program, but we give them an extra 4 weeks if they want to take a little bit longer to complete each stage. And if they want to carry on, we can give them extra things to do. So we thought, okay, well, if we did if we did 2 weeks and maybe collected some data, within the 2 weeks, we assign people to the dynamic arm and the static arm, and we see what we can get. But then we thought, okay, 2 weeks is not going to be long enough because we're only going to then get 2 weeks data on the specific bit of the intervention that we're looking at. So we had to go back to the drawing board and redesign the trial. And this was sort of the biggest change that we've made to it, really. And this is to actually inform the dynamic arm. So we said, so the screen split, so the top part of the screen in yellow is part A of the trial. So this is where we said, okay, we want to recruit 2,000 participants. We're going to target these participants as healthcare professionals and students. 2 people we can access easily, and 2 groups of people we know that have been really affected in our experience, and the literature would suggest as well, both mental health and mental well-being. So we said that we will recruit 2,000 participants and split them in a 1-to-1 randomization ratio to either the dynamic arm and the static arm. And you may have already noticed that at this point in time, static and dynamic are the same. It follows the same trajectory, but we need to develop a model. We need to develop some kind of neural network that will then feed into part B of the trial to say, okay, we've learned this, therefore we can assign you this different task in the dynamic arm in part B. So we've said the way we're going to do that in the dynamic arm is to introduce randomness. So for example, static arm. So 20-year-old woman would be asked what her preferences are for exercise. Do you like running? Do you like cycling? I like running. Do you like running in the morning, the middle of the day, or the afternoon? I like doing it in the morning. Okay, the static would say, right, Annika, go running twice a week in the morning for 2 weeks and we'll reassess you. And at that 2-week period, we then say, okay, Annika, did you do your runs? Yes, no. No, okay, why not? And then a drop-down menu will come of different reasons. And then based on those reasons, we would then reassign. So no, time of day didn't work. So we'd then say, okay, Annika, for the next 2 weeks, you're going to run twice a week in the evening. So that's how the static will run. The dynamic, we want to introduce some randomness. So you'd follow exactly the same path. Annika, run twice a week in the morning. Annika, at 2 weeks, did you do that running? Yes, no, no, why? Because of the time of day. Then the recommendation will be random. So instead of changing, it could either be noon or nighttime, or could stay the same. So there's 1 of 3 random options, not the ones that have been predefined by the experts, which is the static approach. With the aim, hopefully, that when we stop the trial at 8 weeks, we've then got enough data to say, okay, have we got any predictors there? Have we got anything? Is it that all the 20-year-old women that say they like running in the morning actually adhere more if they run in the afternoon? Is it that we see that people's mood improves in the afternoon, and that's when they're engaging with mindfulness more? Okay, so then once we've built the model, the real part of the trial will start, which is part B. And this is where the dynamic arm will actually be an AI. So we'll actually have a model then that we can say, okay, based on these demographics, based on your preferences, based on your progress, we would recommend this. And we are reassessing every 2 weeks via feedback, and so we can then change the intervention every 2 weeks. We know it's really important that both get the same number of notifications, the same number of motivators, etc., etc. So we'll make sure that that actually happens. I guess the next question we came to was, okay, so this sounds easy. How do we get this into MindLamp? And then that's where we came. We thought, okay, great, yeah, we can put these interventions in. We've only got these 2 interventions. We've got mindfulness and exercise. How difficult can it be? And we were very naive, I hasten to add, very, very naive. And so we had to really go back to basics and look at the different parts in mindfulness. And we initially thought, okay, manage. We should be able to just put exercise, mindfulness, upload everything into manage. But we came across problems with JavaScript, with other talking to each other bits that we said, okay, no, that might not be the best way to do it. So we've said that we will probably do everything in Learn and actually have. So the way the mindfulness intervention will work, for example, is the participants will be given a teaching video. So somebody speaking at them on video, telling them this is what mindfulness, this is what you should be doing, this is how you do it, blah, blah, blah. This will be accompanied by a script, so a Word document in case they didn't want to watch the video. Then they'd be given a guided practice. So again, audio visual with a Word document too, to say, this is how you do a body scan, sit there, do this. Then they'd be given homework. So now go and do this practice at home twice a week. And then we want to be able to send notifications to say, okay, I hope you've done your do mindfulness this week, or keep happy, keep strong, do your mindfulness, or how's the body scan going this week? Again, exactly the same ones going to each intervention. We think that the part of MindLamp that we'll use to do the sort of surveys, as they're called, would be definitely the assess bit. We don't see any problems there, because we are keeping it quite basic and simple as so far as questionnaires go, that will mainly just be rating scales. And then I think from my limited dealings with the technical aspects of it, the prevent part, I just think in our pilot trial would just involve too much, and I think would be dashboard only. We're looking to just use the app for participants. And so we thought that for the pilot trial, we'll try and go with the learn and assess, unless we can get them into manage. And we will go from there. The update from our side at the moment, so the team have been fantastic. John, your team have been so good. Aditya has been helping so much, that we had some home truths of, okay, we need somebody to actually set up an Amazon web server for us in the UK. So we're actually doing that, and we think it's going to be a lot easier if we commission somebody to actually set and manage the server up for us. So we're meeting with them tomorrow, and we hope to have that up and done in the next few weeks. And then we can start moving. In the meantime, I'm developing these interventions and the pathway that these interventions can take to then be uploaded and incorporated into the learn part. That was a Paideia in a very quick nutshell. I'm sure we will all be in touch a lot in the next few weeks, months to come. But any comments, questions, helpful tips would be absolutely welcomed.
And in terms of, sorry, now there's no echo about that. In terms of how, it may be interesting how you guys are broadly thinking of kind of using the, or where, how will the machine learning part happen, kind of, or where?
Yes, a very good question. So we're looking to do that will be all in Oxford. So we'll have to, so the challenging thing that we're having in Oxford at the moment is we're having to use three, I'm going to call them platforms. So we've got the Amazon Web Server, we've got RedCap, and we've got Open Clinica. And they all need to talk to each other, unfortunately, which is what we're trying to do. We will completely stop the trial and stop data collection at the point where we're going to be doing the machine learning, and we will look to download the data and do that all in-house. So we've got 2 machine learning experts who will look to just do some simple neural networks to see for any links, any predictors that we can find, who will then write that code for us that will then be incorporated then into the platform.
That makes sense.
I think I could almost do a part 2 of this talk of when we get to that point. Because I think setting up the server was a big thing. And I think the interventions have just, they're so good. The experts have just done such a good job. I think, again, we naively thought they'd have these sort of basic do this. And no, you know, they really do try and personalize things. In the expert approach, that we've had to take it sort of one step further, and we thought, okay, the randomness approach probably is the quickest and actually most interesting at this small scale, to see if we can see any differences and any predictors.
Well, we'll leave it open for questions for like a few more minutes, but thank you so much. That was really great to hear about and to learn. We've been going back and forth a little bit, but getting to actually see what you're doing is just so interesting. So thank you very much.
No, not at all. And like I say, I'd be really excited to update you once we've got the Amazon Web Server set up from here, and got the database all up and running, and then with the machine learning bit as well. I think it would be, yeah, it's exciting, and will pave the way for the sort of bigger trial as well. So, but thank you all. Like I say, you have all helped so much with getting this up and running.
We think Amazon Web Services is the easier way to do it. We've seen some folks are using Microsoft services and it works well, but
Right.
it's a little more plug and play with Amazon Web Services, not because one is perhaps better, but because I think we built it initially. So we knew kind of how to work with it. And they automate it pretty well and pretty easily, but sometimes configuring it to different local, national security standards, or to kind of, each hospital has a slightly different flavor of what they want. And we've also learned that sometimes that can be a little bit tricky or unique to each one, but it's not overly a huge hurdle. But and I said but certainly it can take time, or just a little bit of frustration in that step.
Yeah.
to do it.
So I had a question, and maybe a suggestion, depending on what the rest of the group thinks. I wonder if some of the like anomaly detection methods that like Ian and Phil and you guys have used before might be like a starting point for some of the machine learning models, or are they just completely different?
No, that sounds absolutely. Yeah, I'd love to hear more about that.
I'll send you the papers on it, but no, what Hannah's saying, anomaly detection is nice because you can set, a lot of the analysis we found is very good within subject for smartphone data because people use their phones. So it's harder to find population level effects, but if it's a personal system, it's good for personal insights. And with anomaly detection, each data stream, be it surveys, be it steps, be it sleep, or each feature that you make can kind of be independent, or you try to kind of find somewhat independent features, and then you kind of just look at anomalies or kind of patterns of variance in independent features and look when they kind of cross a personal bootstrap kind of p-value for each person on each day. So it's been a nice way to, we can use all the different data streams. We're not kind of relying on just one.
Yeah.
We've found, at least in our Boston research, is we're kind of trying to predict relapse in psychosis. So slightly different, but usually people have multiple data streams or anomalies together. And no one always, it's not like it's always cognition and steps go offline. It's for different people, it may be surveys and kind of social metrics. It's interesting, and I think clinically that kind of matches what all of us have seen, right? People have different paths towards relapse. Something is happening that's different than their baseline. That's why it's a relapse, but it's really hard to kind of have a unified one. So anomaly detection has been nice with that. There's also one called change point detection that's kind of a less stringent threshold. Yeah. And we've always thought for change point detection, maybe you could begin to pick up kind of, again, things that aren't really quite at the level of anomaly, but maybe are kind of important, something different happens, something interesting in your life, a topic to bring up in a therapy session. So, but you get more false positive. It's just a less stringent change point in anomaly detection, but certainly a good way to use diverse data streams.
Super, thank you.
Are there any other questions, comments? Going once, going twice. With that, thank you so much again, Annika, and thank you everyone for joining, but we will end the webinar here. Have a great rest of your day.